Yes, good evening to everyone. In this video, I am going to be discussing about abnormal molecular masses and Van't Hoff factor. What are the abnormal molecular masses? What is the Van't Hoff factor? Why we are going to be studying about Van't Hoff factor? What is the use of the Van't Hoff factor? Why we need to be studying about Van't Hoff factor? So these are the things I am going to be discussed. So before going to discuss about abnormal molecular masses and Van't Hoff factor, just we need to be collect colligative properties. So we have a four colligative properties. So in that one, first one is in that one, what is the first one here? That is relative lowering vapor pressure. So here relative lowering vapor pressure. So that you can be right here. That is P0 minus Ps upon P0, which is equal to mole fraction of the solute. So mole fraction of the solute we can be write like this. That is number of moles of the solute by number of moles of the solvent plus number of moles of the solute. Like this we are writing. Here I am neglecting the number of moles of the solute. Here I am neglecting that number of moles of the solute. Why I am neglecting that? Because whenever you are comparing with number of moles of the solute, which is very less than number of moles of the solvent. Why? Because in generally qualitative properties are applicable for the dilute solution. In dilute solutions, number of moles of the solute is very less when compared with the number of moles of the solvent. So due to that reason here, number of moles of the solute are neglected. Number of moles of the solute are neglected. So if you write the formula here like this will be changed like this: P0 minus Ps by P0, which equal to weight of the solute by molecular mass of the solute into molecular mass of the solvent by weight of the solvent. So this is the first qualitative property. It is a first qualitative property. Now second qualitative property, what is that? Delta TB, which equal to Kb into molarity. Kb into molarity. So here Kb into molarity. So molarity means what? Molarity means I will be write directly here, that is number of moles of the solute into 1 by weight of the solvent in kgs you need to be taken. In kgs you need to be taken. So if you write the number of moles of the solute formula again, which is converted into weight of the solute by molecular mass of the solute, in the same way we can write the delta Tf, elevation in the boiling point. Delta Tf means what? Elevation in the boiling point. Delta Tb means what? Depression in the freezing. Delta Tb means what? Elevation in the boiling point. Delta Tf means what? Depression in the freezing point. Once again I am repeating. Delta T means what? Depression in the delta Tb means what? Elevation in the boiling point. Delta Tf means what? Elevation in the freezing point. We can write here Kf into here the weight of the solute by molecular mass of the solute into 1 by weight of the solvent in kgs you need to be taken. So this is about depression in the freezing point. This is about what? Depression in the freezing point. So another one, it is osmotic pressure. So osmotic pressure phi equal to N by V. Number of moles of the solute. Number of moles of the solute by volume of the solution into, you can be write here RT. So in other way you can be write here number of moles of the solute means what? Again you can be write here weight of the solute by molecular mass of the solute into RT by V, you can be write like this. So why I am writing all these colligative properties? See, you know that by using the colligative properties, we can determine the molecular mass of the solute. We can determine the molecular mass of the solute. In every case, molecular mass of the solute we can be determined by using these four colligative properties. Now see that Here, molecular, this is actually colligative property. That is what RL will be, relative lowering vapor pressure. So here, molecular mass and colligative property both are inversely related. So colligative property, which is inversely proportional to the molecular mass of the solute. If the molecular mass of the solute increases, colligative property decreases. If the colligative properties increases means what? Mass of the molecular mass of the solute decreases. If it is increases, it is decreases. If it is increases, it will be decreases. So like this. That means what? Both are inversely related. Both are inversely related, and these qualitative properties particularly applicable for the dilute solutions. Dilute solution. In other way, we can be called ideal solutions. Ideal solution. It will be applicable for the ideal solutions. And that means what? Dilute solutions. So here, dilute solutions, and also these are applicable for the non-electrolyte solutions. So they are not applicable for the electrolyte solutions. Electrolyte solutions. These qualitative properties are not applicable for the electrolyte solutions. So what happened? Why they are not applicable to the electrolyte solution? What will be happened when you are taken the electrolyte solutions? Now see that what are electrolyte solution. So here we are introduced that qualitative properties formulas, and here qualitative properties are inversely related to the molecular mass of the solute, and these qualitative properties are applicable for the dilute solutions, and they are not applicable for the electrolyte solution. Now see that why they are not applicable to the electrolyte solutions. So keep in your these points. One is qualitative properties are inversely proportional to the molecular mass of the solute, and also qualitative properties are directly proportional to the number of particles, number of solute particles. So number of particles, they are number dependent properties. Qualitative properties are what? They are number dependent particles. If the number of particles increases, qualitative properties increases. The qualitative properties increases, molecular mass decreases, molecular mass of the solute decreases. So in case of the electrolyte solutions, what happened? Why the qualitative properties are not applicable? Why the qualitative properties are not applicable for the electrolyte solutions? Now see that I will be write that what are the electrolyte solutions. For example, if you have taken that electrolyte solutions like acids, some acids you can be taken care, and some bases you can be taken, some salts you can be taken. For example, I will be write the acids. So what are the acids? So now see that electrolyte solutions I am going to be write. Electrolyte solutions I am going to be write here. What are the electrolyte solutions? Some acid solutions like HCl, hydrochloric acid, and sulfuric acid I will be write H2SO4, and also I will be write what? Acetic acid CH3COOH. And some bases, these are what? Acids. These are what? Acids. If you consider the bases like this, strong bases like sodium hydroxide we can be taken, potassium hydroxide we can be taken, and here magnesium hydroxide or calcium hydroxide we may take here, and here some calcium hydroxide you can be taken here, barium hydroxide you can be taken here, barium hydroxide. These are the bases actually. Now if you consider the salts, like what are the salts here? Sodium chloride salt you can be taken, NaCl, sodium chloride, and also magnesium chloride salt you can be taken, MgCl2, calcium chloride salt you can be taken, potassium chloride salt you can be taken, KNO3 you can be taken, KNO3 you can be taken, and CH3COO, sodium acetate you can be taken. So these are actually salts, and moreover they are the strong electrolytes. So in case of the strong electrolytes, what is the problem? So in case of the strong electrolyte, there is a problem. For example, here I am taking that sodium chloride. Sodium chloride I am taken. Here if I take it is dissociated into Na plus and a Cl minus ion. How it can be dissociated? Sodium chloride which is dissociated into Na plus ion and Cl minus ion. So whenever it is undergoing the dissociation, what is the problem? What is the problem? So here it is undergoing the dissociation like this. It is undergoing in dissociation. So if it is under, just imagine that if it is undergoing the 100% dissociation. So initially I am taken one molecule of the sodium chloride. It is there is initially, what is this one? Initially what I am taken here? one molecule, that is what, one molecule of the sodium chloride taken here. There is no sodium ion, there is no chloride ion. So here after some time what happened, if it is undergo 100% dissociation, so there is no sodium chloride ions, and here one sodium plus ion, one Cl minus ions are there. Now here in case of the initial state, here there is only one molecule, there is only one molecule, but after complete dissociation what happened, there are the two particles. How many particles are there? Two particles. There are the two particles. Initially only one particle is there. Initially only one particle is there. So here what happened here, number of particles are increases in the solution. Number of particles are increasing in case of the sodium chloride solution. Sodium chloride solution. So you know that colligative properties are directly proportional to the number of particles. Number of particles. So then what happened? Whenever the number of particles are increases, definitely colligative property increases. The colligative property increases, that molecular, what happened? Molecular mass of the solute decreases. So why? Because they both are inversely related. They both are inversely related. So here there is a effect. For example, sodium chloride molecular mass, if you are expected x, when it is undergoing the complete dissociation, so that colligative property value, what you are assumed that x, but here because of the 100% dissociation, the colligative property, it is doubled to that expected. It is double to the expected. So colligative properties are increases. Colligative properties are what happen? Increases when in case of the electrolytes. In case of the electrolyte. Why? Because these electrolyte, they may undergo in complete dissociation or small extent of the dissociation. Once the solution, once the electrolyte is undergoing in the complete or small extent of dissociation, there is a change in the colligative properties value. There is change in the molecular mass of the solute. So what you are going to be getting? We are going to be getting some different value for the colligative properties than expected value. So here, whenever you are changing, for example, if you calculated the theoretical value for the molecular mass for the sodium chloride, here according to formula for 20, here sodium chloride molecular mass we are considered like this now. How we are considering 23 plus 35.5. Then here we are going to be getting what? 58.5 we are going to be getting. This is the value, molecular mass of the sodium chloride for one formula unit. You are going to be getting what? 58.5. It may be different, we are going to be getting. Why? Because these are undergoing in the dissociation. So what my conclusion here? So that is, so what you are expecting, the value, molecular mass of the, or else you may call it as a colligative properties for the sodium chloride, we are going to be getting different. Why we are going to be getting different colligative property value means, so in case of the electrolytes, the substance is undergoing in the dissociation. The substance which is undergoing the dissociation. So because of the dissociation, number of particles are increases in the solution. So because of the increasing in the number of particles in the solution, colligative property is going to be increases. Colligative properties are going to be higher value than expected value. So that is the main thing we need to be remember. So like that, whenever the substance are giving some different molecular masses than expected value, that substance we are going to be say that abnormal molecular masses. That substance we are going to be say that abnormal molecular masses. Not only in case of the dissociation, they may undergo in the association. In such case also there is a problem. What problem we are going to be facing in case of the association? Did you understand? In case of the dissociation, number of particles are increases and colligative properties increases. So what will be happen in case of the association? For example, here I am going to be taking that acetic acid. If you are taking the salt, if you are taking the base, if you are taking the acid, whatever the substance if you are taken, that substance if they are undergoing the dissociation, definitely we are going to be getting what? Different colligative property value than expected value. That point we need to be remember. So that point we need to be remember. So because of that reason, we are going to be studying about Van't Hoff factor. So here, before what you written, colligative property, when simply you are writing what a simple formula you are writing. For example, delta TB, if you are taken Kf into Kb into some molarity you are writing. So that may be wrong. So to correct that one, you are going to be getting some errors in molecular masses. What errors you are going to be getting? Because of the dissociation. How much extent it is dissociated, that error if you are finding, you may correct that molecular mass. So because of that reason, so here this Van't Hoff is introduced the factor I, so that we can be called what Van't Hoff factor. So before going to that, once you see that about association also you can see, so then you can be understand very clearly. So you can see that, for example, here I am taking that two moles of this CH3COH acetic acid I am taken. When you dissolve this acetic acid in the benzene solution, it will undergo in the association. It will undergo in association. It will be undergoing in association. So like this, CH3, and here we can write a C double bond O. C double bond O. Here you can be write what O. Here we can be write what H. And similarly, you can be write here hydrogen, oxygen, and C double bond O, and here it is what CH3. Yes, 2 moles of this acetic acid actually I have taken initially. It is converted into 1 mole. So that means what it will can be called what dimerization. So this what happened? Acetic acid which is undergoing in dimerization process. So here dimerization it is undergoing and it is converted into 1 molecule. So 2 molecules are converted into 1 molecule. Then what happened? Number of particles decreases or not? Yes, 100%. Number of particles are decreases compared to the first one. See here I am taken what 2 moles I am taken, 2 molecules I am taken here. So here it is what giving what? Because of the hydrogen bonding. Here it is called what? Hydrogen. Because of the hydrogen bonding. So here acetic acid in the benzene solution undergoing in association and it is converted into 1 molecule. 2 molecules of the acetic acid which is converted into 1 molecule of the and it found what dimerization. See that number of particles definitely what happened decreases. Then qualitative properties what will be happen? Yes, qualitative property will be depending on the number of particles. Number of particles decreases means what? Qualitative property also decreases. So we are going to be getting what? Higher molecular mass. Why? Because if the qualitative property decreases, what happened? Molecular mass definitely increases. So here we are going to be getting what? Higher molecular mass. So then expected value. So here in case of the association, what happened here? So molecules they are undergoing the association means what? If it is a 2 molecules, it will be form what? A dimerization. If it is a 3 molecules, they are undergoing the association, they can be form what? Dimerization. So here tetramerization like this. Whenever you are taking that 4 molecules, is it clear? So here number see only one thing you can one thing remember, that is when the molecules are undergoing association, so number of molecules will be decreased. Ultimately, number of particles will be decreases in the solution. So here qualitative properties which are depending on the number of particles. If the number of particles decreases, definitely qualitative property will be decreased. So if the qualitative property decreases, so ultimately what happened? Molecular mass of the solute will be increases. So this is the factor. So what I am giving the conclusion. If we observe the conclusion, so what is the conclusion here? See that. So here, what is the conclusion means? In case of the you are going to be getting what? Abnormal molecular masses. Abnormal molecular mass is nothing but what? When the molecular mass of the substance, determined by studying any of the qualitative properties comes out to be different than the theoretically expected value. Whatever the value we are expected, we are not getting that value. The substance is said to be show abnormal molecular mass. So, what I'm saying that when the molecular mass of the substance determined by studying any of the qualitative property, you may take what RLBP, you may take what elevation in boiling point, you may take what depression in the freezing point, you may take what osmotic pressure, any one of the qualitative property By using this colligative property, we are going to determine the molecular mass of the substance. So, but what that value we are going to be getting different than theoretically expected value. So that substance, what you are going to say, abnormal molecular masses. Abnormal molecular masses. In which cases you are going to be getting abnormal molecular masses. So here, when the solution is non-ideal, when the solution is non-ideal, we are going to be getting what? Abnormal molecular mass. So here non-ideal means what? It is not a dilute. That is what? Not a dilute solution. Not a dilute solution. It may be concentrated solution. Dilute solution. Not dilute solution means what? You can take concentrated solutions. In case of the concentrated solutions, why we are going to be getting different molecular mass for the solution? Because in concentrate solutions, so molecules are very close to each other, so because of that reason there is some attraction. Because of the attractive forces, we are going to be getting what? Different molecular masses, so then expected value. So that is the reason, so colligative property is not applicable for the concentrated solutions, it only applicable for the dilute solutions, that are ideal solutions. So, and the second one, when the substance when the solute undergo in dissociation, when the solution undergo, or a solute, you can take not solution here, when the solute undergo undergoes dissociation in solution, in solution. In such case also we are going to be getting different molecular mass. That means what? Abnormal molecular mass. In which case here, in case of the non-ideal solutions, we are going to be getting different molecular mass. That is what? Abnormal molecular mass. Then expected value. And when the solute which is undergoes in the dissociation, in such case also we are going to be getting what? Different molecular mass for the solute. And other one, it is what? When the solute undergo in association association, in such case also we are going to be getting what? Different molecular mass for the solute. That means what? Abnormal molecular mass. In the three cases we are going to be getting abnormal molecular masses. So one is when the solution is non-ideal, when the solute undergoes dissociation in the solution, when the solute undergoes association in the solution. If the solute is undergoing the dissociation, we are going to getting what? More colligative property than expected. And when the solute undergoing the association, we are going we are going to get what? Lower colligative property than expected value. So like this you are getting, why you are getting different molecular masses, then you can see that. So in such cases, to rectify that error, Van't Hoff is a scientist, is given a factor that is indicated by I. So that is called what? Van't Hoff factor. So this Van't Hoff factor was given in 1880 year by the Van't Hoff. So now see that why you are going to be study about the Van't Hoff factor. So to correct the molecular mass of the solute. So some errors you are going to be needed to correct that errors. So he is given that the factor that is called what? Van't Hoff factor. So Van't Hoff factor, which is determined by the letter I. So by using this I, we can be determine the abnormal molecular masses. So now see that. What is I? What is I? So I is nothing but what? Whatever the colligative properties we are expecting, experimental value of the colligative property, experimental value of colligative property by observed colligative property, observed value of colligative property.